Of the MCQs on circular motion. In order to refer any textbook, I referred here Maharashtra board textbook. So you can consult any of the textbook which is available in the market. What is circular motion? Options are an accelerated motion, a motion where the speed is constant, motion of a particle about a point outside the object, and the last one is motion of a particle in a straight line. The correct answer is option C, motion of a particle about a point outside the object. Explanation: during revolution, an object undergoes circular motion about a point outside itself or about some other object. This distinguishes it from rotation, where motion is about an axis passing through the object itself. Circular motion is defined as the movement of an object along a circular path about a fixed point. This type of motion involves a change in direction at every point, resulting in acceleration even if the speed remains constant. Example of circular motion is include the motion of the planet around the sun or a car turning around a curve. Second question: what is a key characteristics of circular motion according to the text provided? It is a uniform motion, it is a periodic motion, it is a non-accelerated motion, or it is a linear motion. And the correct answer is it is a periodic motion. Its explanation: circular motion is often periodic because the object repeats its path after completing one full circle. This periodicity is a defining feature of a circular motion, especially in uniform circular motion where the object moves at a constant speed. Which quantities are used to describe circular motion? And the options are linear displacement and velocity, tangential displacement, velocity and acceleration. Third option, angular displacement, angular velocity and angular acceleration. And the fourth, linear velocity and angular velocity only. And the correct answer is C, angular displacement, angular velocity and angular acceleration. Its explanation: angular displacement refer to the angle covered by the object as it moves along the circular path. Angular velocity describes how fast the object is rotating, measured in radians per second, and angular acceleration describes the rate of change of angular velocity, indicating whether the rotation is speeding up or slowing down. Next question is, how is tangential velocity, which is denoted by V, related to angular velocity denoted by omega and the position vector denoted by r? Option A, V is equal to omega plus r, B is equal to omega cross r, C, V is equal to omega dot r, or V is equal to omega by r. The correct answer is B, V is equal to omega cross r. It is a vector quantity, all the quantities are in vector form, and its explanation is the tangential velocity V of an object in circular motion is related to its angular velocity omega and the radius vector r by the cross product. This relationship shows that the tangential velocity is perpendicular to both the angular velocity vector and the radius vector. Question number 5. What is the magnitude of the tangential velocity, which is denoted by V? Option A, V is equal to omega square r. Second option is V is equal to omega r square. C, V is equal to omega r. Or the D option is V is equal to r by omega. And the correct answer is option C, V is equal to omega r. Explanation: the magnitude of the tangential velocity V is determined by multiplying the angular velocity omega by the radius vector r of the circular path. This formula highlights the direct relationship between the speed of the object and its distance from the center of rotation. All the quantities are vector. Next question. How is the direction of angular velocity omega determined? First option is left hand rule. Second, left hand thumb rule. Third, right hand thumb rule. Or fourth, it is always tangential to the path. The correct answer is option C, right hand thumb rule. And explanation is the direction of the angular velocity vector omega is determined using the right hand thumb rule. If you curl the fingers of your right hand in the direction of rotation, your thumb will point in the direction of the angular velocity vector. This rule helps in visualizing the direction of rotation in three-dimensional space. Next question, question number 7. What distinguishes uniform circular motion UCM from other types of the circular motion? First option, both speed and direction of the particle are constant. Second option, the direction of the particle changes but its speed remains constant. Third option, the speed of the particle changes but its direction is constant. And the last option, both speed and direction of the particle changes. And the correct answer is option B, the direction of the particle changes but its speed remains constant. Explanation, in uniform circular motion, the speed of the particle remains constant but its direction changes continuously as it moves along the circular path. This change in direction results in centripetal acceleration directed towards the center of the circle. Question number 8. The acceleration responsible for uniform circular motion is called by what name? That is, first option is tangential acceleration. Second option, centripetal or radial acceleration. Third option, linear acceleration. Or fourth option, angular acceleration. The correct answer is option B, centripetal or radial acceleration. And its explanation, centripetal acceleration is the acceleration directed towards the center of the circular path, necessary for maintaining uniform circular motion. It is responsible for changing the direction of the velocity vector without altering its magnitude. Question number 9. What is the formula for centripetal or radial acceleration? First option is AR is equal to omega square r. Second option, AR is equal to minus omega r. Third option, AR is equal to minus omega square r. And fourth option, D is equal to D. Option is AR is equal to V by r. The correct answer is option A, or it can be option D too. Option A is AR is equal to omega square r, or option D, AR is equal to V square by r. Both answers are correct. Explanation, centripetal acceleration can be calculated using two formulas. AR is equal to omega square r, where omega is the angular velocity and r is the radius, or AR is equal to V square by r, where V is velocity vector and r is the radius. Both formulas describe the acceleration required to keep an object moving in a circular path. There is no negative sign, it is just a bullet over there in front of AR. Question number 10. What is an example of uniform circular motion? First option, a fan rotating uniformly. Second option, the motion of a particle of a fan when it is switched on or off. Third option, the motion of the earth around the sun. Or the last option, option D, a car moving at a constant speed in a circular path. And the correct answer is option B, the motion of a particle of a fan when it is switched on or off. Explanation, non-uniform circular motion occurs when the speed of the object changes over time. An example is a fan accelerating from rest when switched on or decelerating when switched off. In this case, the angular velocity changes, resulting in angular acceleration and non-uniform motion.